booger is heavy.
I'm out.
Okay, wait. It's still going.
I'll hit the red button.
Okay.
And action. For his old lady that he does something down here or what?
Yeah. I like to watch their buttons. If they were in G-strings, it'd be a lot better. Yes.
You just keep standing there. Why you gotta take pictures of this? Does he have voices?
Oh, my arm's about ready to fall off.
Well, you could yell at him and work a little fast.
I think they have to go slow so they can. This is kind of a demonstration case for Mark.
Because my arm really fall off.
And one arm is completely numb.
I believe it.
Karen, will you ask them how much longer?
How much longer should I sit? You can stop.
I look goofy standing here. I'll be ready. When's it supposed to be ready, Doc?
We'll be there in about 2 minutes.
Really?
Yes.
Well, I've been shut that thing off.
Show that you're gonna do that at home. You're gonna like do the dubbing and everything.
Yeah.
Your wife's gonna do that.
Yeah.
Pull up Karen and I found that your wife's gonna sit back and say, "Oh shit, all those late nights and long hours."
Yeah. Kayak.
Get that damn thing out of here.
Hey, John boy.
Who's that?
Peace, man.
Who's that? Huh?
What?
For here, is it yours? Yours?
Touch your
Show that
nose.
tongue.
Touch your nose. Hi, Dean.
It's the largest extrusion research facility in the world, with 2 pilot plants and a working laboratory. Our tech center is in use. Welcome to Wenger Manufacturing, the world authority in extrusion cooking systems. Wenger Manufacturing, a family business spanning 60 years and 3 generations. A business bringing together a workforce dedicated to developing and building only the highest quality equipment. Wenger Manufacturing, where service to customers is just as important as the equipment we build. At Wenger, the difference begins in our technical center. It's the largest extrusion research facility in the world, with 2 pilot plants and a working laboratory. Our tech center is in use 300 days a year for research to make new products possible. We test new ideas that we are developing, and we demonstrate the practicality of your ideas, too. Our technicians analyze your particular extrusion needs and then apply our state-of-the-art technology in test runs. We actually produce product for your evaluation, and we do it in quantities that help you make informed production decisions. Test runs also allow us to design a total system specifically for you as you develop the most marketable and profitable products possible. We're in the business of advancing the technology of our science. No one knows the extrusion business better than the people of Wenger, and no one can better teach you how to use an extruder. We believe each customer is different and has uniquely different needs. We build the best possible system to satisfy those needs. Only Wenger builds both twin screw and single screw extruders. At Wenger, we specialize in single supplier responsibility. We build the whole system for you. Our engineers have hands-on experience. They combine sound engineering concepts with the latest production techniques. Our machine operators, our craftsmen, and our assemblers carefully produce every major component. Computerized machine tools and the personal commitment of all our employees assure quality. When the name Wenger goes on, our customers know they have the finest state-of-the-art extrusion equipment on the market. But the Wenger commitment does not end with building your system. The service we offer puts us head and shoulders above the competition. We provide both pre- and post-installation engineering support. A Wenger technician is with you for the installation of your system. We train your operations staff, and we stay with you until your capacity and product quality expectations are reached. We care about the systems we install, and should something go wrong, we take care of it, period. At Wenger, we maintain a parts inventory for equipment that hasn't been manufactured for more than 2 decades. Remember, at Wenger, we developed the concept of extrusion cooking. The most important advances in extrusion cooking have come from Winger. And you can be sure the advances of tomorrow are being engineered at Winger today. And that's why we're certain we can help you develop new products and produce your current products more efficiently. The heart of the Winger system is the high-temperature, short-time extrusion cooking system, a revolutionary system that Winger pioneered. The system consists of a live bottom bin for mixed raw materials, a variable speed metering or feeding device that feeds the raw, dry mixed ingredients uniformly and continuously at the desired flow rate, a patented preconditioning system where liquids, steam, slurries, or any combination are combined with the dry ingredient mix, an extruder assembly that feeds, kneads, and cooks the dry or pre-moistened process material, a die that provides restriction and shapes the final product, and a cutting device that cuts the product to the desired length. Of course, the entire system may be computer controlled, from the introduction of raw materials to the output of the final product. You expect no less from Winger. It's Winger's system and experience that makes us the industry leader and gives us the know-how to revolutionize the way pasta can be produced. Winger systems are engineered to be durable and efficient, and they produce product in just a fraction of the time needed by traditional methods. And the Winger system can use a range of wheat flour. That gives you greater flexibility in producing your product. Pasta the Winger way is pre-cooked. To make it table ready, it needs only to be rehydrated. That usually takes just 2 to 6 minutes in hot or boiling water or in a microwave. Our system begins with the live bottom bin. It holds and maintains a predetermined mix of raw material for the cooking extruder. The variable speed screw feeder provides a uniform, continuous flow of mixed raw material from the bin to the preconditioner. The screw speed is accurately controlled, and the speed can be manually set or computer-driven. Our preconditioner is a cost-effective way of tempering raw materials by direct steam and heated water injection. This patented system provides you with improved mixing and allows you to control the mixing time of the raw materials before they enter the extrusion cooker. Our cooking extruder can perform several functions very quickly. Preconditioned raw material is carried into the extruder barrel, where it is worked into dough and rapidly heated. Dough is folded and kneaded and compressed, and then pushed through a die plate which determines its shape and size. Due to the unique nature of the extrusion process, cooking and drying time is drastically reduced compared with traditional systems. All parts of the system are designed to work together as it works for you. Compare the Winger system, and you'll see it's less complicated, requires fewer people to operate, takes less floor space, and requires lower capitalization. While traditional systems require a high-quality flour, a long processing time, and high capitalization, the Winger system accepts a much wider range of flours, plus reduced drying time. Best of all, pasta from the Winger system requires just a fraction of the time for the consumer to prepare. Winger offers versatility, economy, and flexibility for you in quick cooking pasta production. Winger is recognized worldwide. In fact, Winger systems are in use today on almost every continent. Our commitment to our customers means we have offices in Europe and Asia. Wherever you are, we work with you in total confidence from concept until your system is installed and working at its promised capacity. We are known for taking new ideas, developing those ideas, and building new machines that produce new products. The Winger Research and Development Team is tops in the industry, and we get the job done quickly.
Well, we've done many years of research with Winger equipment. We find it very durable, very flexible. And another thing we like is their response to our needs. Anytime we've had problems, we find they have been very helpful, and our relationships are very warm.
Have a problem? A quick phone call and replacement parts are shipped promptly. Our vast inventory of parts means less downtime for you.
Our Wenger TX52 twin screw extruder has been in our facility for about 2 years now. It's our most used piece of equipment. We use it primarily for providing assistance to the food industry in Nebraska and nationally. It's a great piece of equipment for that type of research. We can get up to 17 different formulations through the machine or variations through the machine in a day. It gives a great deal of latitude and a great deal of information in a short period of time to our clients. One final thing, the Wenger Corporation has provided technical assistance to us that enables us to serve our clients and to use this piece of equipment as it should be used in this kind of an atmosphere.
That's it. That's the Wenger story. Now, what can we do for you? Our commitment is we care. Our success comes not only in the systems we develop and build, but also in the success that Wenger equipment helps you achieve. At Wenger, we're ready to help you make success happen.
After adjusting the set points on the MOCON temperature controls, I turn them back off until a later time. Brian is now turning the steam gun on, which we will use to preheat the dies and the bells. We'll usually leave the steam on the bells for about 5 minutes on each one, just to preheat them to the point where they feel fairly warm to the touch, but not so hot that you can't keep your hand on them. This time I'm also adding air to the top of the water pump stainless steel cylinder. By adding air to the top, it will drive the piston down to the bottom, and this will help the water pumps and the micro motion machines which sense the flow of the water, regulates the flow of the water, will be more accurate. As you can see, we have steam flowing from the steam gun into the top end of a die and holder. As I put air into the top of the stainless steel cylinder, I open the valve and let the water out of the bottom, so the piston will be able to move down to the bottom of the cylinder. I'm now going into the electrical room to turn on the main DC power, which actually operates the 250 horse DC electric motor which runs the extruder. It has a separate switch control in the electrical room. I make sure that the extruder water pump valve underneath the cylinder is set on water pumps rather than backwash, and just about ready to start the extruder. With clipboard in hand, I will double check as I set points right now on the feed rate for the cylinder. This point in time, I've turned on the lube pump and the extruder with the pot on the extruder set at minimum, which is about 24 RPM. I also have the extruder water pumps on. I have adjusted the water rate according to the set point for the extruder. I have this water flowing out the end of the extruder at this time to help rinse it out. The water in the extruder at this point will not hurt anything when we begin to push dough through it. At this point in time, I turn the stuffer on the extruder. Also, I've turned on the cylinder, the live bin, and the twin screw feed that feeds the cylinder. After watching the digital readout and finding that we are getting our specified number of pounds per hour into the cylinder, I can then turn on the cylinder water feed and the cylinder steam feed and adjust those set points. Right now I'm adjusting the water and steam on the right side to precondition the feed rate, precondition the dough before it is sent to the extruder. At this point in time, the flour which is in the cylinder being mixed will be diverted to a chute which goes into a hopper. After about 5 mixing of product in the cylinder, when it reaches normal running conditions, temperature and moisture wise, then we will be able to divert it back, change the diverter chute and drop it into the extruder and run product through the extruder. After putting air pressure on top of the piston to blow it down to the bottom of the cylinder, I went just now and checked to make sure that the air, after pushing the piston to the bottom, was relieved, so there was no air, nothing but atmospheric air pressure on the top of the piston. We have product coming out of the diverter chute into the blue garbage can. At which point it is too hot to handle with your bare hands and wet enough to where it sticks together when you do pinch it with your fist. It does not crumble apart like a dry flour. Then we'll be ready to move the chute back to the extruder and push it through the extruder. I now have my left hand up on the diverter switch to move the chute. I have my hand on the RPM pot for the extruder, so once we move the chute over to the extruder, we slowly turn it up from 24 RPM up to usually like 160, which for most conditions is our normal running speed. At this point, one must always make sure that the stuffer is rotating, but we do not want the vacuum on, just the stuffer. As you can see, after about 1 minute, we do have wet product coming through one side of the extruder, and before long we'll have a drier product coming through both ends. At this point, the product in the cylinder will actually be wetter than the normal running procedures because of the fact I will be adding about an extra 50 pounds of water into the cylinder during the setup mode. The same with the water going into the extruder. At this time, I will usually put in an extra 50 to 100 pounds of water to keep the product running wetter than normal running conditions. Right now I'm adjusting water going to the extruder. As you can see, the product in the extruder is slowly At this point in time, the MOCONs are still turned off. The only heat going to the barrel is the heat coming from the hot water that we are adding to the extruder during this process. This time, Dean is looking for any black specks that could be rubbing off the walls or the screws of the extruder. We usually keep our eyes on this. If there's black stuff breaking off the walls, we will keep running product through the extruder until we see that it is definitely being cleaned out and the product doesn't contain much, if any, foreign particles. The product is now stiffening up to the point and warming up to the point where it'll break off in chunks. We will run this way for just a few minutes, and then we will shut everything off and attach the dies. Now I'm shutting off the extruder and the cylinder, and the water and steam going to the cylinder. At this point in time, we will begin to get ready to attach the dies to the extruder. Before we attach the dies to the extruder, one must use a power washer and blow the plugs out of the end of the extruder. If the plugs are not washed out of the end of the extruder where the throttle plate is, and the one waits a few too many minutes and then attempts to run the extruder with the dies attached, product will not go through the throttle plate, but will go up through the stuffer, and one can plug up the stuffer and also plug up the vacuum tube. So when the throttle plate is attached and in place, you definitely have to stick the power washer inside of the 1-inch throttle hole and definitely flush it out. At this point in time, the cylinder is off, the steam and water to the cylinder is off, and the water is off going to the extruder. The steam has never been turned on to the extruder yet at this point. The clamps that hold the die to the extruder must be put on in only one direction. They do an important job, and one must be assured that they are tightened to about 100 foot-pounds on each side, as to prevent the actual die from getting blown off the end of the extruder with the extreme pressure. At this point in time, I am adding the knife to the bottom of the die, which is used to cut the product to a specified length. As you can see, Dean has just added the air valves to the top of the air motors, which drive the knives at the bottom of the die. We will then connect the green hoses to these air valves and adjust those valves as necessary so we can meet the specified length of the product which we are running. Blankets have been attached to the die holder, as well as spacers have been inserted on the inside of the dies along the shaft, which is used to hold the stainless steel cone above the die approximately 6 inches. Once the dies are attached, we can then go ahead, attach the power cable to the conveyor belt, which is used to take the product from the dies to the suction tube. At this point in time, all the dryer settings should have been preset. So at this point, we will be able to turn the dryer on, all the motors and fans, and it will be ready to function immediately. Also at this time, we'll turn on the conveyor belt, which slides under the die. We will also turn on the knife switch that actuates the knife blades, adjust the air accordingly so they are running at approximately the right speed for the conditions and product we are trying to match. Excessive speed on the knife blades will cause excessive wear. I usually don't try to over speed the knives until we're actually running product through the die and know exactly what length we have to have. At this point in time, I've just turned on the cylinder, the water and steam going to the cylinder, and I'm adjusting that to match the set points for this specific product. I'm also at this time turning on the Mocons, which feed warm water to the heads of the extruder. Those set points have already been adjusted earlier. I'm adjusting the water and feed rates, water and steam rates going to the cylinder. The feed rate had been adjusted earlier in this tape. Seems how we had the product in the conditioner close to what we wanted earlier, and it hasn't been that long. The product is still hot, steamy, and wet. It shouldn't take but just a minute or so, and we'll be able to divert the chute back to the extruder and begin to push product through the extruder to the dies. At this point in time, the extruder is probably 70 degrees colder than normal running conditions. I'm reaching over the diverter chute to check on the condition of the preconditioned product. Always be sure that the cylinder direction is in the forward direction, and the green light will be on the switch, which you can see directly in the middle of the picture. The cylinder in the reverse speed will actually push the product too fast through the mixer, and the product will not get mixed thoroughly enough to do the right job. Now I have turned the extruder on, at which time I immediately make sure the chute moves over above the extruder and drops the product in. I'm now adjusting the water and steam accordingly, but have not turned on the vacuum. For the next couple of minutes, while we have the product falling into the end of the extruder, I will be looking at the readouts on the extruder steam and water to make sure that they match up with the set points we have specified. At this point, the RPM on the extruder should be still set at 160 or the specified RPM for the given product. Within a minute or so, we should have product coming out of the end of the dies. As you can see on the die on the right, product is not even coming out fully all the way across the die, mainly to the left. Now I'm adjusting extruder water and cylinder water and steam. Now I'm opening the steam valves and the steam ball valve, which lie on top of the extruder. At this point in time, I have not turned on the vacuum. Anytime now, one can turn on the vacuum safely, not suck product up into the vacuum tube once we have the product coming well out of the dies, flowing well. I'm turning on the vacuum right now. When one turns on the vacuum, do check with the vacuum gauge on top of the stuffer to make sure that you do have an open vacuum line and the vacuum shows on the gauge. Usually anywhere from 10 to 12 on the gauge. At this point in time, we have shoved the conveyor belt underneath the dies, and once you do that, one must check directly and immediately up to the airlock to make sure the product is flown through the system correctly to the dryer, to the air, through the airlock, and into the shaker bed above the dryer. At this point in time, the biggest thing is to keep track of the readouts to make sure all the set points and readings match up correctly. Then watch the product coming out of the dies and adjust knife speed for length. And when the product matches the specified length and shape, one can save the product at the other end. The speed of the turn on these twists will all be the same. They should be approximately the same length and shape. This is 4 hours after we began running. As you can see, a lot of dancing with the noodles. They're not coming and flowing straight down out of the inserts. They definitely have a problem. Not a good sign. The dancing is a sign of worse things to come. Here we have a picture of incest to its fullest.